Hello everyone, welcome to our first distance learning official video. Today we're going to be doing lesson 8.2, which is multiplying a polynomial by a monomial. So up until now, what we've done over the last few days is adding and subtracting polynomials. We did the distance formula and midpoint formula the other day over video and worksheet. Hopefully that got accomplished okay. And now we're going to be working on multiplication of polynomials. We're going to start with monomial times polynomial, and then later on we're going to get into polynomial times polynomial. And then we'll work on division after that, which another name for division is sometimes factoring, which is a very important concept moving forward from here, but we need to master this concept first. It's very important that you take your time while you're watching this. Take good notes from home. Rewatch the videos if you need to. I'm going to put homework problems at the end of the video, just like I do homework problems with you in class. I'm going to try to keep homework to a minimum amount that you need to make sure that you understand the concept and are successful. So hopefully everything is going to go well. Don't forget to do your homework after this. You should have until Friday at midnight for this particular lesson, if everything lines up the way we believe it will. Alright, so let's start our discussion. First of all, we worked with monomial times monomial situations earlier. X squared times x to the third. When we multiply monomials, we add the powers. We do not change the bases. So x squared times x to the third is x to the fifth. Another way to look at this is x times x, and this is x times x times x. So when we multiply them together, we have x times x times x times x times x. 1, 2, 3, 4, 5. Now when we add in coefficients, which are numbers in front of the variables, we end up with situations like this. 3x squared times 2x to the third. Now the mistake that a lot of students make when they come across problems like this is that they either multiply both or add both and forget that the coefficients or the numbers out front need to be multiplied just like they would be before. 3 times 2 is 6. And the powers on the variables need to be added. X to the 2 plus 3 is 5. So I end up with 6x to the fifth. Now when we add multiple variables to the situation, step it up one more step to something like 5x squared y times 7x squared y cubed. We're going to multiply the coefficients first. 5 times 7 is 35. Then we're going to add the powers on each variable separately. And the powers on the variables have to stay with that variable. They don't combine to be one power at the end. I saw a lot of that on tests and worksheets coming out here. We need to be very careful. X powers stay on x's. Y powers stay on y's. X to the second times x to the second is x to the 2 plus 2, which is 4. The other major mistake that we make sometimes, and a lot of people made this mistake on the last test, is that this y has a power. Its power is 1. and it often gets forgotten about. Now, a lot of you came across that problem on your test. It had a bunch of m's. It was like m to the third times m to the second times m to the first, and it should have been 3 plus 2 plus 1 is m to the sixth. Now, that wasn't the exact problem, but it was similar to it. A lot of people forgot this 1 and called it m to the fifth, which was not correct. You have to remember that when there is no power, there's a little 1 hiding up there. So that becomes 35x to the fourth, y to the 1 plus 3 fourth. 35 times 4 x's times 4 y's. Now the next thing we need to recall to be able to do this skill is our distributive property. Because basically that's what we're going to be doing throughout this lesson today, is distributing things that aren't just small monomial times polynomial situations. So originally when we talked about the distributive property, we worked problems like this. 3 times 2 plus x. And the way we do that is we distribute in our 3 to both pieces. 3 times 2, 3 times x. 3 times 2 is 6. 3 times x is 3x, so I end up with 6 plus 3x. The two things are different. They're not like terms. Therefore, they cannot be added together. Now, often throughout the lesson that we're going to work with today, there will be situations where after we're done distributing, we may have like terms. Mostly in the later problems, when you have two distributions going on, and then you can do a combination between them, okay? In the early ones, when there's only one distribution, it's very unlikely you'll have any like terms, and you can just leave it the way it sits. But later in the lesson, when you'll have two distribution problems sitting next to each other, it's very often that you have some like terms that you can pull together. And I'll show you what I mean and what that looks like a little bit later. Our distribution problems then scale up to monomials times polynomial problems, which is the center of what we're going to be doing today. Situations like 5w times negative 3w squared plus 2w minus 4. This is just a really large distribution problem. We're taking the monomial out here on the left, 5w, and we're going to multiply it in to the polynomial inside the parentheses. Now that polynomial inside the parentheses has 3 terms, which makes it a trinomial. Which today doesn't make a very huge difference in our lives, but it'll make a big difference going into future lessons, what types of polynomials we have. The situation binomial times binomial is very, very different than binomial times trinomial, or trinomial times trinomial, or monomial times binomial, or monomial times trinomial. So we have to understand what particular situation we're dealing with as we're moving forward. The process is similar no matter what, but there are special ways that we can go about multiplying polynomials in certain situations that only work in specific situations. So we need to make sure that we understand what we're doing. We're taking a monomial times a trinomial in this particular situation. Now I'm going to take this monomial and I'm going to distribute it in. When you're doing this, take your time, do one piece at a time. If you try to do this whole thing all at once in your mind, you're going to get very overwhelmed. Slow it down and take it one piece at a time. The old adage is, how do you eat an elephant? One bite at a time. We're just going to do one monomial multiplication at a time, and slowly, as we push through our distribution, we'll get to the end. Our first monomial multiplication is 5w times negative 3w squared. Remember, we're going to do coefficient times coefficient. 5 times negative 3, negative 15. Again, we need to remember that this w here is w to the first power. So I have w to the first times w squared. When I add the powers, I end up with w to the third power. 15w to the third. That's our first monomial times monomial. Now we can go to our second monomial times monomial. 5w times 2w. Again, one piece at a time. Coefficient times coefficient. 5 times 2 is 10. W times w ends up being w to the 1 plus 1, which is 2. Now that we've finished our second monomial multiplication, we'll do our last monomial multiplication, 5w times negative 4. Coefficient times coefficient, 5 times 4, and because the 4 is negative, it will be negative 20. Now we have w to the first here, but we have no w's here. That would be w to the 0 basically. So 1 plus 0 is 1. 20 w to the first. Now we've multiplied this monomial by that entire trinomial, and that's finished. Go ahead and take a second to make sure you got that down. While you're working on that, I'm going to throw up a couple of problems from the homework that you're going to work on. So, I'm going to go ahead and do it in the space over here. I have space over here. For those of you who want to follow along, the homework is on page 501. And we're about to kick off a couple of problems out of it. So again, this works the same way. This is a giant distribution, problem number 20. We're going to take this monomial and multiply it in to this polynomial. This polynomial has 4 terms, 1, 2, 3, 4, which makes it a quadrinomial, for those of you who didn't remember that. One monomial at a time. 3m cubed times 2m cubed. Coefficient times coefficient. Negative 3 times 2 is negative 6. M cubed times m cubed. Remember to add the powers. M to the 3 plus 3 is 6. Next, monomial times monomial. 3m cubed times 12m squared. Coefficient times coefficient. Negative 3 times negative 12 is positive 36. Again, when we multiply our variables, we add our powers. M cubed times m squared is m to the 5th. Next, monomial times monomial. 3m cubed times 2m. Coefficient times coefficient. Negative 3 times 2 is negative 6. Variable times variable. M cubed times m to the 1st is m to the 4th. Last, monomial times monomial. 3m cubed times 25. Coefficient times coefficient. Negative 3 times 25 is negative 75. M cubed times no m's is m cubed. That one is solved. This next one is one of the more difficult ones in the homework assignment. I have 2 distributions that I'm going to do at the same time. And on top of that, I'm probably going to have some like terms that I have to put together when I'm done. I'm going to separate them using color so that everybody can hopefully keep track of what's going on. Here's my first distribution. Here's my second distribution. Now when I distribute this second part, that is going to come into play, and we'll talk about that when we get there. Starting down here. 2j times 7j squared k squared. Coefficient times coefficient. 2 times 7 is 14. J times j squared. Remember, this is j to the 1st becomes j to the 3rd. Now I have no k's over here, and I multiply by k squared, so it stays k squared. Second monomial multiplication. 2j times jk squared. Coefficient times coefficient. 2 times 1, because there's a 1 hiding out there, is 2. J times j is j squared. No k's times k squared is k squared. Last one. 2j times 5k. Coefficient times coefficient. 2 times 5 is 10. J times no j's is j. That's obvious. k times no k's is k, jk. Alright, let's go to the second one. This 9k as we distribute it in is going to be negative the entire time. So we need to make sure that we're distributing a negative 9k as we multiply it in. Negative 9k times 2j squared k squared. Coefficient times coefficient. Negative 9 times negative 2 is positive 18. There are no j's here. There are 2 j's here, so I have j squared. I have 1k here and 2 k's here, so that's k to the third. Again, we're going to go into this second one. Negative 9k times 2k squared. Coefficient times coefficient. Negative 9 times 2 is negative 18. K to the first times k squared is k to the third. Last one. Negative 9k times 3j. Coefficient times coefficient. Negative 9 times 3 is negative 27. Now, we should always keep these alphabetical, so j should go next. J times no j's is j. K times no k's is k, jk. Now I want to look back at this and figure out if there are any like terms that I should put together. And I should also look and see if I can put this in a better descending order. Now, if descending order becomes the issue, don't worry about that, okay? I don't want you focused on, oh, this is wrong because it's not in descending order. If you have all of this work and it's done correctly, there is no way that I'm marking that problem wrong at this point in time. Okay? You have done excellent, excellent work, and I am not worried about it. However, if you want to take it to the next level, we can move this slightly further. There is nothing I can combine with this 14j to the third k squared. This is a j squared k to the third. That's different than a j to the third k squared. So this is on its own out front. 14j to the third k squared. Similarly, this one has very high powers, so I'm going to move it next into 18j squared k to the third. Technically, it doesn't matter which order these two are in. They're completely interchangeable. But they need to be out front if we're actually going to be in descending order. Which, again, we don't really have to be, but it's best if we are. Having those two checked off our list, the next one down the line would be this j squared k squared. It also does not have a partner, so we're going to put it out there next. 2j squared k squared. That one's good. And the next one is this 18k to the third. It also does not have a partner. There are no other k to the thirds, so it is hanging out on its own. All four of those don't have like terms. They have to be the exact same variables to the exact same powers to be like terms. Don't start tucking things together that look kind of similar but aren't exactly the same. And don't put things together and add powers at this point in time. When you multiply things together, you add the powers. When you add them together, they have to be like terms, and you do not change the powers. A lot of people like to try to combine all this stuff together to make it as small as possible right now, and that just isn't possible with what we currently have. It can't shrink up anymore. Nothing is going together like that, except these next two. This 10jk and this negative 27jk are like terms. Now, like I said before, if you do not notice that, if you have circled my red and blue answer here, it is 100% correct. Circle it, move on, don't worry about it, and you've done great. But if you want to continue forward and challenge yourself a little bit here by identifying like terms, there is one here. 10jk and negative 27jk are like terms and can be added together. 10jk plus negative 27jk is negative 17jk. I add the coefficients. 10 and negative 27 makes negative 17. But I leave my variables alone. J to the first, k to the first. There's the solutions to a couple of the tougher problems from the homework assignment. This is more typical of what you're going to see, but there are a few like this down at the bottom. They're going to challenge you a little bit, and hopefully you'll be able to get through them okay. If you have issues, remember that I'm going to open up some time where you can Zoom me, or you can email me with any questions that you have. Make sure to answer these questions and get them turned in as soon as possible so that I can get them corrected and in the grade book, and then you can be successful. Also, let me know really soon if things are going wrong, because if something is going wrong, if you're having trouble posting assignments on Schoology, if you're having difficulty with anything, if you're struggling on this homework and you really need to get on Zoom and you're feeling pressure to get it done right now, email me, let me know. I do not want anyone to feel overwhelmed right now. I want you to feel good about this situation. I want to feel good about this situation. So let me help you if you need help. Alright, the homework assignment today is problems 18 through 29. That's 12 problems, and hopefully they'll go pretty smoothly. I've already done 2 of them for you, and if I have a bunch of feedback on any of them, I'll try to do 1 or 2 more and post them at a later time. Either that, or I'll get on Zoom and help people out.